VR technology is thundering forward at a tremendous rate, as are cloud-based services that stream gaming content to your television. Do we have a future world where VR is enabled by standalone devices making use of cloud compute? Let's find out. So we've had an incredible 12 months from a VR perspective. We've had a myriad of new headsets, we've had increased resolution, the first really feasible 6 degrees of freedom standalone VR headset. And we've also seen some tremendous changes in the gaming space. So Google have launched their cloud-based gaming streaming services, Google Stadia. This is a far more impressive proposition than it first appears, and many skeptics, I'm sure, would believe that there'd be a whole heap of latency introduced through the use of this service. And whilst it's not as crisp and sharp as 144 Hz on a PC-fueled RTX 2080 Ti, it's still very viable and very playable. The latency requirements for VR are a little different. Most VR headsets, in order to keep that immersion and prevent what is quite nasty motion sickness on occasions, require a sub 20 millisecond response time or latency, which is movement to pixel response, MTP for short. Now, this isn't achievable through most fiber-based networking services. Most of us are going to be getting something like 35 to 50 milliseconds of response time, perfectly adequate for monitor, flat screen-based gaming, but not quite sharp enough for VR. In swoops 5G, boasting a cell phone device to radio transmitter base station latency of less than 1 millisecond. Now, whilst you'd have to add some time into this because you're not going to have the compute platform sat right next to your radio transmitter, there's still some time to go from that to the cloud services and back. That's really very impressive. Sub 1 millisecond. That's better than some gaming monitors. Now, there is a catch. There is an Achilles heel to this technology that means it's not quite viable for today's market, but certainly setting us up for the future. And that is, in order to achieve these very, very, very low latencies, it uses a very limited range of frequencies. Now, that limits the total amount of data that you can put through it. Many of us are familiar with the concept and term of broadband. Literally, that refers to a broad band of frequencies in use, which enables faster data rates. To achieve the sub 1 millisecond latency, this is narrowband technology. So whilst the latency is there, the data throughput is not. A typical 4K signal at 30 frames per second is using something like 40 megabits per second, and this narrowband technology isn't going to come anywhere close to this. It's really designed for Internet of Things type technology, some control of robotics, removing the need for edge compute in warehouses and factories, and also the potential future use for the controlling of autonomous cars. None of those things need data rates quite like a VR headset does, but imagine a headset of the future with at least 2 4K displays, one for each eye. You're talking something more in the order of 100 megabits per second. Now, you can't achieve that with the low latency that 5G is bringing. Is the introduction of the Oculus Quest far more profound than perhaps we realize? Yes, it's awesome as a standalone compute platform. Yes, it's awesome it's got hand tracking. Yes, it's awesome that it's introducing the ability to tether to your PC. But a standalone headset with some local compute, 5 or 6G network, ultra low latency, with PC-fueled graphics run out of the cloud on a subscription-based service, materially reducing the entry cost to VR, making it much more widely accessible to people. sounds like a world in which we want to live. So let me know your thoughts on this. Do you see a future world with cloud-provided compute services powering incredible graphics on standalone VR headsets? As always, I hope you're really well wherever in the world you are. Please like, share and subscribe, and I will see you in my next one.